All right, get this for a strange fact. When TSMC, the world's most advanced chipmaker, started building its brand new factory in Arizona, it had to ship a basic chemical, sulfuric acid, all the way from Taiwan. We're talking about a 6,500-mile supply line. I mean, that's just a wild question, right? Why on earth would a state-of-the-art $40 billion facility need to import something so fundamental from clear across the Pacific Ocean? Well, it turns out the answer to that simple question pulls back the curtain on this incredibly complex story about what it really takes to make the chips that run our entire world. So what we're really talking about here is TSMC's Arizona project. This thing is a flagship of America's massive, multi-billion-dollar effort to bring chip manufacturing back home. The plan seemed simple enough. Just build a perfect copy of their world-beating factories. Yeah. They quickly learned that you can't just hit Control-C, Control-V on a $40 billion factory. So, what's the deal? Why is it so ridiculously hard to perfectly duplicate a semiconductor factory, a fab, as they call it, even when you're the undisputed best in the world at it? As you'll see, just putting up the building is like the easy part. Okay, so the game plan initially was super clear. It followed an industry mantra called copy exact. The whole idea was to build a perfect clone of TSMC's most advanced fabs in Taiwan, right there in the Arizona desert. Every machine, every process, every little detail, totally identical. On paper, it's a perfect plan. What could possibly go wrong? And to really get why this whole copy exact thing is such a big deal, we need to talk about the one number, the one metric that rules the entire chip-making world. And that magic word is yield. Yield is just the percentage of perfect working chips you get off of each one of these silicon wafers. Think about it. A single one of these wafers can cost up to 17 grand to make. And when you're building circuits smaller than a virus, one tiny little speck of dust, poof, millions of dollars of product, gone. So yeah, getting a high yield is everything. So to protect that precious, precious yield, you got to control literally every single variable you can think of. That's why copy exact is so obsessive. We're not just talking about using the same multi-million-dollar machines. No. We're talking about the exact same brand of pumps, the same grade of steel in the pipes, even how long the wires are. Any tiny little change can send the whole delicate process spiraling. And if you think that sounds like overkill, the stakes are they're astronomical. This number you see, $550 million. That's how much money TSMC lost back in 2019 from a single bad batch of chemicals. One mistake snowballed into over $500 million in useless wafers. And this really gets you into the headspace of this industry. For these companies, this level of control, it's not paranoia. It's flat-out survival in a business where there is zero margin for error. So you see, TSMC knew they had to copy everything exactly. But what they were about to find out is, you can't copy-paste Mother Nature. And this is where that beautiful, simple idea of copy exact really starts to run into trouble. Because, the Arizona desert is not Taiwan, and all those subtle differences in the environment, they created a whole new set of puzzles for the engineers to solve. I mean, think about it. You can't just copy the dirt under the factory, or the local water supply, or even the air around you. And in this game, every single one of those things matters. A lot. Right away, these differences started throwing wrenches in the works. Now, Arizona's stable ground was actually a bonus, but the local water had a totally different mix of minerals, which meant they had to completely re-engineer their ultra-pure water systems. And the dry air, while good, also came with these massive dust storms they call haboobs, a total nightmare for a cleanroom environment. A manager at TSMC had the perfect analogy for this. Trying to copy the process was like baking a cake at a high altitude. You've got the same ingredients, you've got the same oven, but the air pressure, the environment itself, has changed everything. You basically have to relearn the entire recipe from scratch. But okay, dealing with nature, that was just the warm-up act. The biggest challenge wasn't the natural world. It was the man-made one. See, TSMC wasn't just building a factory. They had to build an entire industrial ecosystem pretty much from thin air. And when you put them side by side, the difference is it's night and day. In Taiwan, TSMC sits in the middle of this incredibly dense web of expert suppliers that's been built up over 30 years. Need some crazy specific gas or a tiny replacement part? It's probably a 10-minute drive down the road. In Arizona, that whole web just wasn't there. They had to bring in everything, from chemicals to the expert technicians themselves. And boom, this quote right here from TSMC's CEO, it brings us right back to our original mystery, the sulfuric acid. He said point blank that American suppliers couldn't produce chemicals pure enough for their needs. And even if they could, the price was 5 times higher. It was actually cheaper to just ship it 6,500 miles across the Pacific. And this kicked off a really painful domino effect. First, you have this huge construction boom, which creates a massive labor shortage. Because of that, the cost for suppliers to build their own new plants just ballooned. We're talking 4 to 5 times what it would cost in Asia. So what happened? A bunch of key suppliers hit the brakes, delaying or even stopping their own Arizona projects. That left TSMC holding the bag with a super long and fragile supply chain.
Okay, so let's zoom out. What does all this mean for the big picture? All these boots-on-the-ground challenges have very real consequences for the cost, the timeline, and the big strategic goals of bringing chip manufacturing back to the US.
Well, the first, and maybe most obvious, consequence is cost. It's just flat out more expensive to make the same high-end chips in the US. By some estimates, it's somewhere between 50 and 100% more expensive than it is in Taiwan. And hey, don't just take my word for it. That's coming straight from the legend himself, Morris Chang, the guy who founded TSMC. He says it bluntly, costs in Arizona could be nearly double what they are in Taiwan, thanks to higher costs for labor, construction, and the whole supply chain. The next big hit? The timeline. All these problems, especially not having enough skilled workers for construction, meant one thing: delays. The original target to start pumping out chips in huge volumes was 2024. Now, that's been pushed back to 2025. So at the end of the day, this isn't really a story about failure. It's more of a huge reality check. It proves that onshoring this kind of advanced manufacturing is so much more than just putting up a building. It's about recreating an entire ecosystem. That's a process that takes decades, not just a few years, and it's going to come with higher costs and longer waits. But hey, there is a silver lining. This massive undertaking is basically kickstarting a brand new tech hub, what people are calling the Silicon Desert. And all of this leaves us with one last really big question to chew on. The CHIPS Act is throwing a ton of money at this problem, but is money alone enough to just create a complex, high-tech ecosystem overnight? Or is it something more like a forest that has to be carefully seeded and grown over time? How we answer that is going to define the future of technology for decades. No pressure, right?